In 4.2, we are going to study matrix multiplication. Matrix multiplication is a little bit different than scalar multiplication. In order to multiply two matrices together, in order to multiply matrix A times matrix B, the number of columns in matrix A must equal the number of rows in matrix B. In our first matrix on the left, the number of columns must equal the number of rows in our second matrix. Let's look at an example that explains this. My first matrix is my matrix A and my second matrix is my matrix B. I first have to decide if matrix multiplication is possible. My first matrix has 1, 2, 3 rows, 1, 2 columns. So this first matrix is a 3 by 2 matrix. This second matrix has 1, 2 rows and 1, 2 columns, so it is a 2 by 2 matrix. So if I look at the columns in my first matrix, it's this second number, and the rows in my second matrix, it's this number. So these middle two numbers have to be equal. In this case, 2 and 2 are equal, so I can perform matrix multiplication. The outside two numbers, 3 and 2, will be the dimensions of my answer. In order to do this matrix multiplication, I'm going to draw a wide 3 by 2 matrix. These outside two numbers tell me the dimensions of my answer. I'm going to draw a wide 3 by 2 matrix, and I'm just going to put lines in place of all the entries in my matrix. Notice that my lines are really long. I need a lot of space in order to write my answer down. This is a 1, 2, 3 by 2 matrix. 3 rows, 2 columns. Now I need to figure out where each number goes in this matrix. So how do I perform the actual multiplication? I need to use linear combination. I need to multiply the corresponding entries in the rows of my first matrix times the columns in my second matrix. And then I need to add those products. So if I look at this first matrix, I'm going to multiply using all my rows in my first matrix and all the columns in my second matrix. Rows by columns, just like the dimensions of a matrix. So I'm going to take my first entry, 3, and multiply it by my first entry in this column. 3 times 1, 2 times 0. If I had a third number, I would just take that number times this number. So I've multiplied the corresponding entries, and then I need to add their products. So I'm going to have 3 times 1 plus 2 times 0. And I'm going to put that answer in this spot right here in my matrix, in row 1, column 1. 1, 1 will be the entry 1, 1 in my answer. To figure out entry 1, 2, I need my first row and my second column. So I'm going to take 3 times 2 plus 2 times negative 1. And I'm going to put that right here. Row 1, column 2. Now I'm going to drop down to my second row, which means I need to drop down to my second row in my first matrix. Row 1, column 1. So I'm going to take row 1, column 1. Negative 2 times 1 plus 1 times 0. Write that right here. Switch to my second column. Row 2, column 2. Row 2, column 2. Negative 2 times 2 plus 1 times negative 1. Now I'm going to drop down to my third row. So I need to drop down to my third row here. Third row, first column, third row, first column. 0 times 1 plus 4 times 0. Third row, second column. Third row, second column. 0 times 2 plus 4 times negative 1. Notice how I've written down all my numbers before I've performed any math. The number one mistake that students make is they try to do all this math in their head and they lose track of where they're at. Write out this step, then you can use your calculator to perform the operation. 3 times 1 plus 2 times 0 is just 3. 3 times 2 plus 2 times negative 1 is 6 plus negative 2 is 4. And continue on down the road performing all of these operations to get your final answer. 3, 4, negative 2, negative 5, 0, negative 4. Let's try one together. My first matrix is a 2 by 2 matrix. My second matrix is a 2 by 3 matrix. My middle two numbers are the same, so I can perform this operation. My outside two numbers will tell me the dimensions of my answer. So my answer is going to be a 2 by 3 matrix. So I'm going to draw a wide 2 by 3 matrix. Hit pause and write down what you think the answer should be. In my first row, first column, I'm going to take this row times this column. 4 times 5 plus negative 1 times 3. In my first row, second column, I'm going to take 4 and negative 1 and linearly combine it with negative 2 and 12. 4 times negative 2 plus negative 1 times 12. In my first row, third column, first row, third column, 4 times 4 plus negative 1 times 6. In my second row, 1 times 5 plus 7 times 3. Second row, second column, second row, second column. 1 times negative 2, 7 times 12. Second row, third column, second row, third column. 1 times 4, 7 times 6. After I've set up this matrix, now I can actually do my math. I just need to perform these operations and get the correct answers. The last thing we need to cover is the order of operations. In the matrix world, again, order of operations is hugely important. I have to perform the math the way that the problem tells me to perform the math. If I look at this first problem, I have 2 times 3 times 4. I need to take 2 times 3 and get 6 and take that answer times 4. Now 6 times 4 is 24. Notice that 4 was on the right side and it stays on the right side. This problem is slightly different. The order of operations tells me perform this math first. I need to take 3 times 4 first and get 12, and I need to take 2 times that answer. Notice that the 2 is on the left side. The 2 needs to stay on the left side. If I switch the order in the matrix world, I'm going to get the wrong answer. Now I can take 2 times this answer and get 24. Now I got the same answer, but I got the answer a different way. I have to perform the order of operations the way that I'm told. In the last problem, the order of operations says perform what's inside the parentheses first. 3 times 4 is 7, and I need to take 2 times that answer. Again, notice the 2 is on the left. It has to stay on the left. So I need to take 2 times this answer. 2 times 7 is 14. Make sure you perform the order of operations the way that it tells you to.